Hey everyone, Roos here. Welcome to this special edition of the Pickup Show, the show where the algorithms are always accurate. In this episode, I'm going to demonstrate how to assign constant values to variables in Google Spreadsheets for use in calculations, and also how to build what I like to call a control panel. So let's get started. If you haven't already, fire up a Google spreadsheet. Google Sheets is the short name for it, of course. And let's start up in the upper left corner here. What I'm going to do in column A, I'm going to define a list of variables, or the business world, I guess, maybe refers to variables or parameters as names. And so I'm going to use the terminology of the business program, this Google Sheets program. We're going to call parameters names. Now, I'm force of habit, I will probably use the word names, variables, and parameters interchangeably, so don't be confused. Right? So we're going to define the names or the parameters we're going to use in some sample calculations here. We're going to list them in column A, and adjacent to each one in column B, I'm going to define the location of the actual values that the spreadsheet will know them as. So how do we do this? Let's start out, let's say we're going to do some kinematic calculations here. So I'm going to do x initial, some v initial. I'm using _0 like a subscript here. Let's say we need some acceleration. That's good for now. And now in the first one, x0, in box B1, I'm going to highlight it. This is where I'm going to tell the spreadsheet where the value of x0 is going to be located. Right? So I'm going to highlight this, and then watch as I move the arrow up to the left here, that name box magically appears. This field is called the name box. I'm going to highlight this, and I'm going to type exactly the same thing as I have in the label column. So the box adjacent to x0, I type in the name box x_0. Now it's very important to hit enter. If you don't hit enter and you start clicking around before you hit enter, it really can screw the system up, and then you have to correct it in a little different way. I'll show you in a moment. All right, so what I just accomplished, let me demonstrate what I just accomplished here. So if I click somewhere else and then come back to B1, you'll notice that the name box still indicates x_0. That means if I put any value in here, any numerical value, the spreadsheet will know that that value is supposed to be associated everywhere with x0. Let me demonstrate. Let's say for whatever reason we wanted our initial position to be 65. I don't know why we would do that. So I'll enter 65 there, and then somewhere else, doesn't matter where, say here, let's assign this box the value of x_0. Now look what just happened there. This is a very nice functionality of the program. It recognizes that I did indeed define something, some variable or some name called x_0. It colors it orange, and it actually, I think that's orange, and it actually provides a color coordinated background behind the actual value, so I can, in other words, it shows me where it's located. It's a very, very useful thing. If I hit enter, I'm going to hit enter 3, 2, 1, and it does indeed assign that box what I told it to, the actual value. Right? So this is very useful in doing calculations, especially computational calculations in a spreadsheet, as you'll see. Let's say we wanted to change our x0 to lucky 7. How about? Right? Now I'm going to hit enter in 3, 2, 1, enter. And when I hit enter, you can see it automatically or instantaneously changed the value of that box I had assigned the value of x0. And you can use this anywhere. You can use this in iterative calculations, any kind of calculation, even graphics. Changing the values over here will change the values anywhere you've used x_0. This, by the way, is why I like to call what I'm building here with more than one parameter or more than one name. I like to call this a control panel, because you can control all your parameter values from here and change things in the spreadsheet. Let's define V0 and A just like we did for X0. So the box adjacent to V0 is highlighted. I go up, highlight the name box, and type in V_0, the exact same thing as the label here. All right? And now let's say we want the initial velocity to be 0, and I can go anywhere. Say here, let's assign this box V_0. Look, it color codes it again for me. And so that's just a way to check to make sure you got things defined correctly. Hit enter and it's all set. A, let's define A. We've got to go up to the name box. I'm going to type A, enter. Don't forget to hit enter. I'm going to demonstrate for you in a moment how to fix things if things get out of hand, which they sometimes do. Let's say we're doing a free fall problem of some sort. We want the acceleration of due to gravity be negative 9.8 meters per second squared. Let's assign this box A, and it does the color coding thing again. By the way, if you ever want to get back and look at what you've programmed, just do a double click on the box and you can see what you've assigned. All right, so there's the color coding again. All right, so let's get rid of these values, and to get rid, just do a backspace or a delete. It clears everything out. Let's say you did make a mistake, or for some reason the spreadsheet just isn't behaving with this name box, and so there's something called, and I think you get to it from here, there's something under this data drop down menu. Go to, it says named ranges, and this little field pops up over here. Right, so what I'm going to do, I'm going to say add a range, right? And so this is the same thing I was doing in the name box, but a named range, I guess that's what they mean by parameters. You can actually associate an array of numbers also with a particular variable, very much like a programming language, but we'll keep it simple and do single scalar parameters here. Let's say I want a delta t. I'm going to use dt. And I could take time probably and make that an uppercase delta, but let's just not be confused. Let's not confuse this with an infinitesimally small amount of time. Let's just say this is a delta t we want to use in a calculation, right? A finite delta t. Now currently it looks like where I had selected, it's thinking that's where I want the value to go. But I want to add this delta t to the list. So I'm going to eventually type dt into box A4 over here. And then I want the named value of dt to go right here in B4. So I'm actually going to change this. You can see the syntax there. We just need to change, instead of F6, I'm going to change it to B4. Okay, click done. And now there's this dt has been added in the name. So if I go over here to B4, right here, let's highlight it. You'll notice in the name box it's expecting that location to have the value of whatever dt is. Let's add it to the label column now, dt. See, that completes my little control panel here. So the value of x underscore 0, initial position is 7, initial velocity 0, a is that. dt, let's say 2 seconds. Right? Now let's do another calculation. Let's change this to 0. Let's say we want initial position and initial velocity, initial position to be 0. Let's throw something into the air. Let's say we've got a ball, we're going to toss it into the air, close to the surface of the earth, so the acceleration is negative 9.8 meters per second squared. Let's say we toss it at 10 meters per second. That's the initial velocity we give it. We toss it from some origin, and let's say we want to know what happens some delta t equals 2 seconds later. So it doesn't matter where we do it, let's do the calculation here. And this is a simple, the famous 1/2 at squared equation. So let's calculate this. This is equal to x0 plus v0 star delta t. Now look, this is interesting. It's color coding things here. So look, the orange for x0, and it didn't put a background. It's got this little dotted line, orange line around it. For V0, what color is that? It's not quite black. Looks kind of purplish, maybe. I don't know. Anyway, there's a purple line around V0, and it made that purple. I'm using the parameter dt here. It did put a little background until I write the next one, then I think it'll make that a dotted line too. Point is, it makes it really easy to follow and make sure that you've got everything defined that you expect to be defined. So I'll use 0.5 instead of a half. Let's put A in. It's identifying where A is located, changes the letter as well as the background color, and times dt. Don't forget to raise it to the second power. Right, if we hit enter, then we find that our ball, whatever it is, that was tossed upward at 10 meters per second, 2 seconds later will be 0.4 meters above its initial position at the origin. Just as one more little example, how useful this is for calculating things. Let's say we do the exact same thing on the moon, and instead of negative 9.8, it's negative 1.6. right? And as I hit enter, 3, 2, 1, you can see now this has changed, our calculations changed, and now, of course, on the moon gravity is less, and we're a bit higher than the origin than we would have been on the Earth. We're at 16.8 meters. Remember, if you ever want to see what you've programmed, do a double click, and you can get it back with everything color coordinated here, with all the variables you define matching the lettering in the programmed statement there in the programmed line.